The Richmond Park project is looking at different ways to intercept road runoff and stopping contaminants getting into the Beverley Brook. I'm Dr. Samantha Hughes. I'm a Senior Water and Land Stewardship Officer and I work at the South East Rivers Trust, and I manage the project here in Richmond Park.
Beverley Brook is a river that runs through here at Richmond Park. It unfortunately doesn't quite meet its target of good ecological potential in the Water Framework Directive. I'm Ben Puddy, I'm the Regional Technical Manager at Hydro International, and I've been helping the South East Rivers Trust manage the Downstream Defender project at Richmond Park for the past 2 years.
We already have a very good working relationship with Hydro International based on past projects. What we're looking at here is how we can use the Downstream Defender to stop contaminants from road runoff getting into the Beverley Brook. So we're intercepting drainage pathways, the sediment drops out into the Downstream Defender and it stays out of the Beverley Brook, so it helps to improve the ecosystem.
Downstream Defender is specifically designed to treat surface water runoff and has done for many years over thousands of different projects. So it's basically an ideal choice for treating surface water runoff for an urban area before a river. And we are in London. It's obviously ever increasing urban areas, and have things like cars leaving pollutants on the ground, and they'll be washed off into the river as well. Also, it's been deepened and widened in places as well, so this has slowed the flow rate down, which has led to sedimentation and sediment dropping out into the riverbed and covering it.
It's important that the water is monitored and treated because we're looking at aquatic ecosystems which are an essential part of the environment that we live in. So we want to keep them as healthy as possible. We do that by testing infrastructures like Downstream Defenders and then monitoring the results to see how efficient they are.
It has quite a few different benefits. It comes pre-installed inside a concrete chamber or a plastic chamber. So this means when it's delivered to site, it can be dropped straight into the ground and the pipe's connected up, giving you a quick installation. It also has quite a small footprint, being just a chamber, compared to other treatment devices, say some natural suds. So the two combined together give you a really good, cost-effective and quick installation.
What it will help to do, together with other measures in the catchment over time, is improve the state of the ecosystem, and the classification for the Water Framework Directive will hopefully improve. With
the Downstream Defender, you actually have isolated polluted zones. First one is when sediment enters the device, it drops into the sump and gets captured underneath a benching skirt. So when flows do come in, it can't reach to the sediment and pick it back up. Floatables, when they enter into the device, they float to the surface, so the opposite direction. They get trapped there. And there's also an integral bypass inside the Downstream Defender. So when you do have very large flow rates, flow can bypass all the pollutants as well. So there's no way any captured pollutants can actually be washed downstream into a river. Say it's roughly about every 12 to 15 months this Downstream Defender needs to be maintained. So all you need to do is get a vacuum tanker to site, and then you empty the sump and empty the pollutants caught on the top. It's safely done from the surface. For this device is the first time we actually try to remove the need for those inspection visits by putting smart monitoring equipment inside it and forming what we call an integrated sediment alarm. This sediment alarm is built up of a water level sensor, a sediment sensor and a data logger. It means that we've been able to maintain it when it needs maintaining, not when it's half empty or not when it's overfull. I think in 1 year, something like over 5,000 kilograms of contaminated sediment. When you're preventing that amount of contamination going into a stream, the feedback is positive.